Hi everyone, I am M. Seshagiri from Vardhaman Engineering College, Triple E Department. Welcome to BW Lab. Before going to start the lab experiments part, we need to have some introduction about the basic concepts of electricity. Is for CSC branch, AML branch, CSD branch, CSM branch. So even though they belongs to computer science branches, it is essential to everyone to know about the basic electrical concepts. All are applicable in their lifetime when they have got a job opportunity to work with the electrical manufacturing industries to write a program for controlling the electricity. Everyone should know the basic concept of the electrical current. So basically current is defined as the flow of charge or flow of electron. If an electron moves from one place to another place, then we can call it as current. So will an electron move with its own efforts? No, needs some energy. We have to provide some pressure between 2 points. It is called potential difference. If you create the potential difference from higher potential to lower potential, the electron will make move. So that is called voltage. In other terms, it can be called as electromotive force. The motivation force which is required for an electron to move from one place to another place is called electromotive force. Or in other terms, we can call it as voltage, the pressure difference, the force which is required for an electron to move from one point to another point, or potential difference. In three terms, we can define it as voltage, EMF, electromotive force, and potential difference. So this is about the current and voltage. So can anyone see current with our naked eye? Not possible. So how we recognize the current? So there are some effects of electric current. The main effects of electric current, when current passes through some types of conductors, the heat is dissipated in that conductor and comes out in the form of light. That is called heating effect of electric current. The second effect is called chemical effect. So you might have learnt about electrolysis process. Take a container, take a chemical solution in and dip two rods into that solution. During the chemical reaction, the solution will divide into two parts. One is traveling towards anode, the other one is traveling towards cathode. Thus, current is created due to the chemical action. This is also one effect of electric current. Third effect is magnetic effect. Every current carrying conductor will create the magnetic flux around it, though we cannot see it, but every current carrying conductor produces magnetic flux around it. With that property only, the motor will rotate. These three are the main effects. One more effect is there, laser effect. If you pass an electron from vacuum tube, get illuminated and deflected on the screen. So that is the principle to work CRO, cathode ray oscilloscope. So with that, we can able to see the path of the electron. So current is of two types, AC current and DC current. AC is the alternating current which passes in sinusoidal shape. The electron is taking, so if you represent the AC voltage, so between voltage and time scale, so the electron is taking this type of path. This shape is called sinusoidal shape. That means we can understand that every instant of time, voltage is changing in magnitude as well as in direction. Thus it is called alternating current. For every instant of time, it is going to maximum peak, it is going to zero, again it is going to negative peak, and again it is coming to zero levels. So every instant of time it is changing its magnitude as well as its direction. The other form of voltage is called direct current. There is no zeros. Always at any instant of time, if you check, voltage will be maximum. So we have two types of voltages, AC voltage and DC voltage. Now the question comes, which voltage is dangerous for human body? As all of you know, if you touch any live conductor, you will receive a shock. The severity of shock is more in the DC when compared to AC. Because the reason is, AC, it may come to zero at any instant. If you touch the live conductor, there is a chance of leaving you. But when coming to DC, it is always maximum. It will catch hold you till your life taken away. So it will catch hold you, which is danger for human body, and sometimes you may lose your life also. So when we are doing experiments with DC, we should take utmost care It is not like that both voltages are danger for human body, but the severity of the shock is more in DC when compared to AC. Already explained you the reason. In AC it may come to zero at any instant of time, but in DC there is no zeros. Now frequency exists in AC only because cycles are there. The entire part of this cycle, it is called, starting from 0 to maximum, minimum and 0 is called one cycle. Like that, in AC voltage we have Indian standard frequency is 50 cycles per second. This is called frequency. 50 cycles it can able to produce in 1 second of time. That is called frequency. But in DC frequency is 0. There is no cycle, there is no frequency. This is about the two forms of voltages. Now let us discuss about some safety precautions we need to take, and unfortunately if anyone touches the live conductor, they will receive the shock. Shock can be explained as is a turning or twisting sensation obtained in your nervous system. It will squeeze your nerves and stops the blood circulation, which causes heart failures. So that is the definition of the shock. So now to protect our human body, because human body is the good conductor for electricity. So there are two types, conductors and insulators. Conductors which allows electric current through it, and best examples are copper, aluminum, all metals. And when coming to insulators, which doesn't allow the current to flow through it, wood is the best example for insulator, rubber is the best example for insulator. You might have observed for all wires we are using, there is a rubber sheathing done on the conductor to provide human body to receive the shock from the current carrying conductors. So rubber is the insulator. So better you should be well insulated when you are working with the electrical equipment. The best way is everyone should wear leather shoes, because for the flow of current a circuit needs to be closed. The circuit is the comprising of some passive elements and active elements and closed. When it is closed only, there is a possibility of current flow from higher potential to lower potential, which is closing here. So if you unfortunately if it happens to touch any live conductor, it will flow through your human body, but the leather shoes which will stops the current to close in the earth. So thus the severity of the electrical shock will be reduced, which is not life threatening. So every student should wear leather shoes. This is the basic safety precautions we need to take in the BW lab experiment, because we are doing some second cycle experiments on motors on 220 volts DC. As I have already explained you, DC is most dangerous than AC. It is not like that AC is also danger. So we are doing 3-phase voltage which is 440 volts on an induction motor, and single phase voltage on transformers 220 volts 50 hertz. So second cycle experiments we are doing, so everyone should know the safety measures. Anyhow, we have taken utmost care in the laboratory by installing rubber mattings which is tested for 440 volts, ISO tested, Indian Standard Organization tested. Everyone should stand on the rubber mat and do the experiment. And this laboratory is well earthed. Earthing means the earth potential is 0. We have taken all the metal parts. So from earth terminal, we have taken a GI wire, galvanized iron wire, which is a good conductor for electricity, and buried into the pit. So everyone should know there is a socket in your home, electrical socket will be there. There are 3 holes in that socket. One is phase, the other one is neutral, the third one is earthing. That earth point is taken through GI wire, galvanized iron wire, running towards all the metal parts and buried into the pit which is outside of this building. There is a pit big, and there we will fill the pit with salt, sand, charcoal, and a pipe is buried into the pit and maintained wet conditions, and whenever accidentally some short circuit occurs, there causes a heavy leakage current which is danger for your human body. So all the leakage current is taken away from earth terminal and taken to earth. Since the earth potential is 0, it will become 0. Thus it protects from electrical shocks. So that type of earthing is done in the BW lab. So there is no such accidents happened so far. but it is very essential to everyone to take utmost care when doing experiment. The basic thing is, the very important thing is, unless you know something, you do not play with the electrical equipments, you do not switch on the power supply. Okay? So we will train you. We will sit along with you. We will train you in a proper instructions we will give you, and we ask you to switch on the equipment after better training. Then only you are supposed to switch on the equipments. Otherwise, sometimes students may rotate some voltages. They play with the equipments. We don't know the situation of that voltage knob. If you unknowingly switch on the power supply, it may rotate in the infinitive speed, which damages the motors. So that is the reason I asked all the students not to switch on any equipments without knowing. That is only the important thing you have to follow. And everyone should wear leather shoes. And one more important thing is, girls will come with loose hair. It is very danger while working with rotating devices. You need to bend towards the motor and take the speed of the motor while rotating with an instrument which is called tachometer. You have to insert the tachometer into the shaft of the rotating device. While doing that, if hair falls on the rotating device, it is danger for you. So I will ask all the girls, tie your hair tightly and keep inside of your apron and come to this laboratory, particularly in this lab. These are the major safety precautions I would like to explain, and everyone should strictly follow the safety precautions. We have displayed in the notice board also. And when coming to the experiment parts, in BW lab we have 6 experiments on theorems verifications, and second cycle 6 experiments on 2 experiments on transformer, OC, open circuit test and short circuit test and single phase transformer, brake test on separately excited DC motor, brake test on self-excited DC motor, brake test on 3-phase induction motor, open circuit test on alternator. So all 6 experiments are second cycle experiments which are on motors, and the first cycle experiments are all basic electrical engineering theorems like Ohm's law, KVL, KCL, Kirchhoff voltage law, Kirchhoff current law, superposition theorem, Thevenin's theorem, Norton's theorem, and impedance calculations. These 6 experiments are related to first cycle, and we are doing all the experiments under 30 volts of DC or 30 volts of AC, which is not at all danger for you. But even though the input to the instrument which is supplying 30 volts is 220 volts, so same precautions you need to follow for first cycle as well as second cycle. So I already explained you a circuit comprising of passive elements and active elements closed. When it is closed, only current will pass through the supply. Active elements are voltage sources. This is the representation of DC voltage source, and AC voltage source is represented like sinusoidal symbol. Always positive symbol is for this line and negative symbol is for this line. And when positive and negative is there, this is definitely a DC source, and AC source is represented with phase and neutral. Whichever supplying energy to the circuit are called active elements, and passive elements are defined as whichever will take the current and dissipate the power is called passive elements. Best example for passive elements are resistors, capacitors, inductors. Right. When coming to the resistor part, resistor which resists the flow of current. Resistor will resist the flow of current. So represented with R, in the units for resistor, resistance is the property of a resistor which opposes the flow of current, and resistor symbol is this, and it is having 2 terminals, and the units of resistance is ohms, and the symbol for ohms is this. This is the resistor, and it is having color band on the top of the body. By seeing the color coding, we need to decide the value of the resistance. I will tell you the shortcut to know the value of the colors. So there is a shortcut method which is called BB Roy, Great Britain, Very Good Wife. This is the color code. BB Roy, Great Britain, Very Good Wife. So B means black, again B is brown, red, orange, yellow, blue, violet, green, grey, white. So these are colors. BB Roy, Great Britain, Very Good Wife, and the value is given as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every color has its own value. Black is for 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, grey 8, white 9. So there are 3 color bands on this top of the resistor. So apart from 3 colors, there is another color which is in gold color, which represents the tolerance of the resistance. Every resistance value will have its own tolerance band. Tolerance is nothing but acceptable deviation. If it is manufactured for 1000 ohms, it will never be equal to exactly 1000 volts. There is a tolerance limit is given for this resistor. It is plus or minus. So every color will have its own value, plus or minus 10%, plus or minus 20%, like that. So you can observe the gold color on the extreme corner of the resistor body. The color code is taken opposite to that gold color. The sequence of the color code is taken to the opposite of that gold color, not considered from the gold color side. So everyone will have a doubt whether we have to see the color code like this or like this. First, to see the gold color, and opposite to that color, gold color, you need to consider the color code. I can say there is a color code of brown in the first band, black in the second band, red is the third band. I'll write on here. Suppose this is a resistor, brown, black, red and gold. This is gold. Opposite to this side, you need to see the sequence of the color. So this is brown color, this is black, this is red. Always first color represents the first digit value of the resistance. Second color represents the second digit value of the resistance. Third is always multiplier of 10 power. If red is there, we need to take 2 on the power. So first color is brown. Brown stands for 1. Second color is black. Black stands for 0. Into third color is 10 power 2. That means 10 into 10 square, 1000 ohms, or in other terms we can call it as 1 kilo ohm. So like that we need to calculate the color code. So everyone should remember these values and code. B.B. Roy, great button, very good wife. Suppose I will write 2200 ohms color code. So first 2 means red. Second 2, again red. After that 2 zeros are there, 10 power should be 2. So for that I need to write R. So first color is 2, second color is 2 into 10 power, R is 2. So that is 2200 ohms, and in other terms it is called as 2.2 kilo ohm. Next I will write 3300 ohms. 3 means orange, 3 again orange, 2 zeros means red. O-O-R. Orange, orange, red. So 4700 ohms. 4 means yellow, 7 means violet, 2 zeros always red. If 3 zeros are there, you need to write orange. Yellow, violet, red. It stands for 4700 or 4.7 kilo ohms. And next coming to 33,000 ohms. That means orange, orange, 3 zeros means again 10 power 3 should be there. So orange I have taken. This is the method of calculating color code. So everyone asked to take the appropriate value which is given in the circuit task. You need to select the appropriate resistor by seeing the color code from the bunch of resistors. So like this we will calculate the color code. Now let us come to the measuring instruments what we are using in this laboratory. So everyone knows that there is a voltmeter which measures the voltage, how much voltage we are giving as input to the circuit. Suppose this is the source. If I connect the voltmeter across the source, remember one thing, voltmeter always connected across the source. Positive is connected to positive terminal of the voltage, negative is connected to negative terminal of the voltage. And there is another ammeter which measures the current. Ammeter always connected in series, voltmeter always connected in parallel. Never connect ammeter in parallel, never connect voltmeter in series. This is a fundamental rule. So I have connected an ammeter in series with the resistance value and closed like this. Now the current passes. If I apply 15 volts, let us say for example, this will read this 15 volts set in the source, and the current consumed by the resistor is displaying here. Depends on the resistance value, it may be amperes or milliamps. There are two types of ammeters, milliammeter, ammeter. And so by increasing this voltage, you can read the voltage which is applied at input part, you can read the current which is consumed by the resistor. This is about the instruments what we are using. So particularly to see this, there is a source which is called regulated power supply. There are two types of regulated power supplies: dual power supply, single power supply. Dual power supplies, it is having two channels. Single power supply, it is having single channel. This is called regulated DC power supply. It is having two channels, channel 1 and channel 2. So this is the common display for channel 1 and channel 2. You need to select the knob. If you keep it in channel 1, this will be active, and the voltmeter voltage display which is showing for these two terminals, channel 1 terminals. And if you keep it in channel 2 mode, these two will be active. This is not a display for channel 2. This is only the common display for channel 1 and channel 2. So for channel 1 side and channel 2 side, we have a control knobs. The top one is called current, always keep it in maximum. The second one is called course, which is used to set the higher voltages values. The third one is called file, which is used to set the decimal point. Suppose I want to set 10.8 till 10 volts, we can use course knob, and decimal points I have to set 0.8. So by varying the point knob, you can set the decimal values: 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 can be taken by using the file knob. Suppose in some circuits we need to take both the voltage sources. It is having two sides voltage sources. There we can use the dual power supply, set some voltage in the first channel, set some voltage in the second channel, keep this knob in any way, both voltages will work on the circuit. Then we will use dual regulated power supplies. Like this we have a voltmeter also. Like this we have a voltmeter, and it is also having two terminals which is connected parallelly in the circuit. It will measure the voltage, whatever the input we set from the source. We have again two types of voltmeters: AC voltmeter, DC voltmeter. Again we have two types of ammeters: AC ammeters and DC ammeters. Depends on the input supply what we are giving, we need to select the type of the ammeter. And one more instrument what we are using in this laboratory, this is called breadboard. It is having vertical lines, and so this is breadboard, and this is consisting of some vertical lines and some horizontal lines. You can see backside of this breadboard, like the construction of breadboard will be like this. So all vertical lines are connected like this, vertically with a plate. That means you should understand that from the first hole to last hole there is a continuity. So it is not having continuity in the adjacent rows, column. So these all lines are connected vertically. So if any two elements are to be connected, you have to carry out in the same vertical line. I'll show you practically. So this is the construction of breadboard, and horizontal two lines are given. These are all like this, it is connected. So it is having horizontal continuity. So whenever two elements are connected, you have to carry out in the same horizontal line, not like in vertical line. If you select these lines, you should carry out in vertically. If you select these lines, you have to carry out in horizontal line. This is about the construction of breadboard. And one more thing, we use these wires. These wires are called connecting wires. It is having lead at the two edges. By connecting, there is a hole terminal. There is a hole in between this terminal. You have to insert this wire into that hole like this and tight this. Thus make the connection. All these wires are taken into the breadboard. If positive is connected, you have to connect the positive terminal into any one of the line. So whichever the element connected to this positive terminal, you have to carry out in the same vertical line. So thus we will connect the circuit. Now let us come to the first experiment, which is called Ohm's law. This is the same circuit. So here Ohm's law states that in a room temperature, if you increase the voltage, current also increases. V is directly proportional to I. So current increases with the increase of voltage. If you release the power proportionate symbol, V equals to I into, there will be a constant which is called resistance, R. V equals to I into R. So we can derive so many formulas from this. I equals to V by R, R equals to V by I. In any way, if two parameters are known, the other unknown parameter can be found out. That is the calculation method. So from this, there is an R value, there is an ammeter, there is a voltmeter, and there is a voltage source. It is a variable source. You have to apply at least 2 to 3 different voltages and observe the current, whether it is increasing or not. I1, I2, I3, I4, like this. So your observation is Ohm's law. In a room temperature, the current increases with the increase of voltage. That is the verification, first theorem.